Good morning, students. Today we'll try to solve the miscellaneous exercise from the differential equation mathematics class 12th. Let us try to solve few numericals from the miscellaneous exercise. Okay, so we have differential equation, differential equation. Capital is the now we'll try to solve miscellaneous exercise first. Okay, miscellaneous exercise. Okay, so now let us begin. We have the question. First question they have given. In this first question, we have 5 parts. That is d square y upon dx square plus 5x dy upon dx whole square minus 6y is equal to log x. Second, I have dy upon dx whole cube minus 4 dy upon dx whole square plus we have plus 7y is equal to sin x. Now the third part is d2y upon dx4 minus sin d cube y upon dx cube is equal to 0. So here we have 3 parts, and the question is, in this we need to find the order and degree. We all know that is what is order, how many times one is differentiated, that is the order. So here we can consider that is order is 2. Order is 2. And second we have order is 1. And in third case we have order is 3. Now we can see here the highest order having the power 1. So degree is 1. Okay. And in second case and in first case, let us try to find what will be the degree. Okay. So if we consider here, that is in second case the highest power is 3. So degree is 3. And in first case the degree will be 1 because we consider the highest order. So highest order power is the degree. So it is 1. So that is how we able to find the order and degree. Okay, so now we have the second question here. What they have given, let us see. In second question they have, we need to verify the function that it is a solution of corresponding differential equation or not. Okay, so we have the first question part. They have 4 parts here for second question. Now first we will consider the first part. Now the first part they have given y is equal to aex plus be minus x plus x square. This is the solution, and we have the differential equation x d2y upon dx square plus 2 dy upon dx minus xy plus x square minus 2 is equal to 0. Okay, so let us see that it is a solution, explicit or implicit solution of this given differential equation or not. How to find? First we need to find dy upon dx and d2 upon dx square, so that after differentiating twice, we'll put the value here and try to solve it and try to find the solution that is have to be 0. Okay, so let us try how we can do it. First, dy upon dx aex minus be minus x plus 2x. Okay, and what is d2y upon dx square. That is, I am differentiating again. So what I found is aex plus be minus x plus 2. So now I have to put the values here. So we have x into aex plus be minus x plus 2 plus 2 into aex minus be minus x plus 2x minus xy plus x square minus 2. Okay, so let us try to solve this. What we got here? X aex plus x be minus x plus 2x plus 2aex minus 2be minus x plus 4x minus xy plus x square minus 2. Okay, so let us see. X a raised power x, we don't have this. Okay, so we have here x a raised power x plus b raised power minus x. Okay, here we need to 2 into divided by dx. Okay, so this is a solution. Okay, but if we consider it, what we got here? 2x plus 4x, it will be 6x and minus 2. So we can put here x aex plus x be minus x plus 2x plus 2aex minus 2be raised power minus x. No, here we'll put plus 6x. Okay, we have sorry, plus 6x we have. Then we'll say minus xy. Then we have plus x square minus 2. Okay, so this is given. So we find that this is not equal to 0. So we can say that this is not a solution of given differential equation. Okay, so now let us try to solve. Okay, let us try to solve. Now we have second part of this question now. Okay, we have done first part. Now we'll try to solve second part. So we have now second question, second part. Let us see what they have given in this. What they have given in this, that is, now we have second part. Y is equal to e raised power x a cos x plus b sin x. Okay, so they have given this, and then the equation is they have given is what I have given the equation, that is d2y upon dx square minus 2 dy upon dx plus 2y is equal to 0. Okay, so now we'll try to solve this. How we'll solve? First we'll need to find the first, we'll multiply this. Okay, so y is equal to ex a cos x plus b e raised power x sin x. Okay, this is they have given. Now what we will do, we'll try to find the dy upon dx. We'll try to find dy upon dx here. So a is constant, so let's take it first function, second function. We'll try to solve the u. Okay, so e raised power x minus sin x plus e raised power x cos x plus b e raised power x cos x. Okay, plus b e raised power cos x plus b e raised to the power x sin x. Okay, so I have this. They have given minus aex sin x plus aex cos x plus bex cos x plus bex sin x. Okay, so we have this. Now we'll try to solve it further. Now I have this. Okay, so now we'll try to solve d2y upon dx. That is, we need to differentiate it again. Okay, so what they have, we can do same thing here, minus a uv e raised power x cos x. Okay, and minus a e raised power x sin x. Okay, plus here also will apply uv, that is a e raised power x minus sin x. Okay, plus we'll have a e raised power x cos x, plus b e raised power x minus sin x. Sorry. Then we have plus b e raised power x cos x. We are applying uv differentiation. U first function into differentiation of second plus second function into differentiation of first. So like this we have done. Now what we have done here, we have sorted out this. Okay, for a cos x we have done this. Then we have done this one, bx plus this. Okay, now plus b e raised power x cos x plus b e raised power x sin x. Okay, so now we can see here it is negative and it is positive. It will be reduced. Okay, bex cos x here. Now similarly, if I see here aex cos x negative, so it is reduced. Okay, now so what else we have? We can see minus 2aex sin x plus 2bex cos x. Okay, so we are left with this. So we have find this and this also. Now try to put a value here. So minus 2aex sin x plus 2bex cos x minus 2 into dy upon dx minus aex sin x plus aex cos x plus b e raised power x cos x plus b e raised power x sin x plus 2 into y. What is we have? Y e raised power x a cos x plus 2 here wait e raised power a cos x plus b sin x. So we'll multiply it later. Okay, while opening the bracket. So now let us open the bracket and let us see what happens. Minus 2a e raised power x sin x plus 2b e raised power x cos x plus 2aex sin x minus 2ae raised power x cos x minus 2b e raised power x cos x plus 2b, wait, we have done this, minus, well, it will be minus 2b e raised power x sin x plus 2 e raised power x a cos x plus 2 e raised power x b sin x. Okay, so we have this. Now let us see what we can do here. Now very simple way, minus 2, so it will be reduced. Okay, so now we have 2b ex cos x, it will be reduced. Now we have 2a cos x negative, and then it is, so we got 0. So we can say this is the solution of the given differential equation, because we got here RHS equal to 0, which is required. Okay, so now let us try to solve the third part. So why a simple thing, miscellaneous exercise is there, so let us try to solve now third part. Now we have the third part is there. So now what they have given, let us see. Third part is y is equal to x sine 3x, and the given differential equation is d2y upon dx square plus 9y minus 6 cos 3x is equal to 0. Okay, so now let us try to find whether this solution is for the given differential equation or not. Now let us first do it dy upon dx. Well, again try to differentiate according to the u. Okay, so u is x. Now it will be minus cos 3x by 3 plus we have sin 3x. Okay, so now again differentiate it. So we'll try to differentiate it again. So we got here 1 upon 3 outside, now minus, so we have x into minus sin 3x upon 3, sign different, no, it is positive. Okay, so now we have this sin 3x by 3, okay, plus we have cos 3x. Okay, so this is what I have, plus we have cos 3x by 3. Okay, so I can multiply here inside, minus sin 3x upon 9 plus cos 3x upon 3 plus cos 3x upon 3. Okay, so I got it, minus sin 3x upon 9 plus 2 cos 3x upon 3. Okay, so I found it this. Now let us try to put in this differential equation so that we are able to know that this solution is for this or not. So now put this value, minus sin 3x by 9 plus 2 cos 3x by 3 plus 9 into y, 9x sin 3x minus 6 into cos 3x. Okay, so now they have given this, but we can say this is not equal to 0. Okay, so we can say that this is not a solution of the given differential equation, whether it is implicit or explicit. Okay, so now let us try to solve the another part I have, that is x square. Okay, now let us try to solve the another part. These three parts are solved. Now let us try to solve another part we have, that is x square. We have x square is equal to 2y square log y. Now here I have x square plus y square dy upon dx minus xy is equal to 0. So now let us try to solve. First we'll find the, here we have that is they have given 2y square log y, x square is equal to this much. So what we can do here, if I differentiate it, So I got 2x is equal to 4y dy upon dx. Wait. Now let us try to solve this. What we get here? 2x is equal to 2 into dy dx of y square log y here. Okay, so I have, so x is equal to dy upon dx of this y square log y. So what will happen? 2y dy upon dx, 2y dy upon dx log y plus y square into 1 upon y, log y difference 1 upon y dy upon dx. Okay, so now what we can do here, take dy upon dx common, so we have 2y log y plus y. Okay, we have dy upon dx x. So therefore dy upon dx will be x upon 2y log x plus y. Okay, so now let us try to put here. So I got x square plus y square into x upon 2y log x plus y minus x into y. Okay, now minus x into y. So what will be y here? If I try to find, it will be, if I say, it will be x will be there. Wait. Let's try to find the y. Now leave as it is xy. Okay. So now what I got here, x square plus y square. Okay. So now I have this x upon this much we have, no? Wait. Now what happens? Put the value of x square. 2y square log y plus y square into x upon 2y log x plus y minus xy. So now what we can do here, we can take here, that is y square common. So if I take y square common, I got 2 log y, 2 log y plus 1 into x upon, I can take common y here. So 2 log x is there, no? So 2y, so I am taking y common as log x plus 1 minus x. So now we can consider this, and y is reduced. So what, xy minus xy is equal to 0. So now we can consider this, that this is the solution, that is implicit or explicit, of the given differential equation. Okay, now let us try to solve the third question now. Now let us try to solve the third question now. We have just solved only two numericals. Now we will try to solve third question from the miscellaneous exercise. Okay, so now the third question, what the third question says, let us try to see that they have given the, we need to form the differential equation representing the family of curve given by x minus a whole square plus 2y square is equal to a square. Okay, where a is an arbitrary constant is given. Okay, so we need to form the differential equation. Okay, so now on a family of the curve given by this. So how to form the differential equation? Let us see. Open this. We know the formula, a minus b whole square, a square plus b square minus 2ab plus 2y square is equal to a square. So now we can say 2y square is equal to 2ax minus x square. If I differentiate 2y, dy upon dx is equal to 2a minus 2x. 2y dy upon dx is equal to 2a minus x. Okay, so we got y dy upon dx is equal to a minus x, or I can say dy upon dx is equal to a minus x upon y. Okay, what else? Now we have 2y dy upon dx, so we have we have y square we have, so it will be 4y, sorry, it will be 4y dy upon dx. So if I reduce this by 4, I got 2 here. So 2y dy upon, it will be 2y. Okay, so now what we can do, multiply with the, here we will multiply with 2x. So we got dy upon dx is equal to 2ax minus, I multiply with 2x, 2x square upon 4y. I multiplied with 2x, so it will be 4xy. So I got this. Okay, dy upon dx, that is 2x minus 2x square plus 4xy. If I need to find the value of 2ax here from here, so 2ax it will be x square plus 2y square. Okay, so I got this. Now what we can do here is put this value in this equation. This is the second we got. Okay, so now this is the first one. Now let us try to, this is the first try I got. Now try to put this value here. So I got dy by dx is equal to x square plus 2y square minus 2x square upon 4xy. So I got 2y square minus x square upon 4xy. So finally, I got my differential equation in which no arbitrary constant is available. So that is how we form the differential equation of the family of the curve given by this. So here is arbitrary constant. Okay. Now let us try to solve the fourth question now. You can solve here if it is, we have the space. Okay. So now let us try to solve this. Okay. Now we'll try to solve the fourth question now. What they're saying is, now the fourth question they have, that is, we need to prove that x square minus y square is equal to c into x square plus y square is a general solution of the differential equation. Okay, general solution of the differential equation we have y square dx is equal to y cube minus 3x square y dy, where c is a parameter. Okay, so now they have given this, so we need to prove that this is the, this is a general solution of this differential equation. Okay, this is the parameter. Now let us see how we can do it. Now we can write this in the form dy upon dx is equal to x cube minus 3xy square upon y cube minus 3x square y. Okay, so now this is the homogeneous differential equation as having the coefficient of both having the same degree. Okay, so now what we can do here is let substitute y is equal to vx, dy upon dx is equal to v plus x dv upon dx. Now put this value and substituting y is equal to vx. So we have x cube minus 3. So vx, we have vx v square x cube, v square x cube upon y we have vx. So v cube x cube minus 3 into vx cube minus v is equal to x dv upon dx. Okay, after knowing that the given differential equation is homogeneous, we will substitute, that is we'll take y is equal to vx. Okay, so now what happens, take x cube common here, so we have 1 minus 3v square upon x cube common here, v cube minus 3v. Okay, so I have this minus v is equal to x dv upon dx. So now let us see, we have what, 1 minus 3v square minus v4 plus 3v square. Okay, so I got this x dv upon dx. So what I got here, 1 minus v4. So we have x dv upon dx, will take 1 upon x dx, integrate it. Here I got dv upon 1 minus v4. Okay, so now I got this. So now we'll see, here I got log x. Okay, so here I have log x plus c is equal to, here we need to apply the formula. Okay, 1 minus v square upon a square, that is a square minus x square. It will be, that is we have, now we have this. Okay, so what we can do here in a very simple way, that is upon v cube minus 3v. So now 1 upon x dx, it will be equal to what? We'll have v cube minus 3v upon 1 minus v4 dv here. Okay, so now it will be log x plus c is equal to, we have v cube dv 1 minus v4. Okay, we'll separate this, so we'll got 3 v upon 1 minus v4 dv. Okay, so now let us try to implement this. It's a very long question we have. So now after getting this, we'll try to integrate it. Okay, take this I1 and I2. First we will consider I1 here. Okay, so they have v cube upon 1 minus v4 dv. What will happen? Put 1 minus v4 is equal to t, so that minus 4v cube dv is equal to dt. So we have minus 1 upon 4 here, we have dt upon t, it will be minus 1 upon 4 log t. What is t? 4. Okay, so now this we have done. Now let's take I2. What we can do, I2 in here, we can take v dv upon 1 minus v square upon square. I can write v raised to 4 as v square whole square. Okay, so now let us see what we can do. Put v square is equal to t, so that 2v dv is equal to dt. So I have minus 3 dt upon 2 here. So I have this 1 minus t square. We all know the formula here, 1 upon 2 log of 1 minus t upon 1 plus t plus c. We can take minus 3 upon 4 here, log of what is t? We have taken v square upon 1 plus v square plus c. Okay, so this we have. Now putting the value of I1 and I2 in this, I got log x plus c is equal to Here what you got here? Minus 1 upon 4 log of 1 minus V4 and minus, so I've just done, so it will plus and 4 log of, okay. So now I got this. Now what I can do? Put the value of v. What we have taken? Y is equal to vx, so we will y upon x. So log x plus c is equal to minus 1 upon 4 log of 1 minus y4 upon x4 plus 3 upon 4 I have log of 1 minus v square 1 minus y square upon x square upon 1 plus y square upon x square. So finally I got this. Okay, so now what we can do further, we can take log cx, we'll take minus sign common here. Okay, and we have log of a4 minus b4, I can write into 1 plus y square upon x square. Okay, so now into we have this in a whole cube I have, that is 1 plus y square upon x square का whole cube upon a whole cube. Okay, now so now let's do it further. Now what will happen, we can take this as, so now we have this, we can write log of cx is equal to, it will be reduced, so it will have minus 1 upon 4 log of, it will be reduced by 1 and it will be 1 plus y square upon x square whole 4 upon 1 minus y square upon x square, we have here 3, so it will be 2. So it will be cx is power minus 1 upon 4 when taking power that side, and here I have got 1 plus y square upon x square upon 4 into 1 minus y square upon x square 2. Okay, now so now it will be reduced, so it will be left as cx minus 1 upon 4 is equal to x square plus y square x square minus y square, but it is 4, it is square, take that side, x square minus y square will have x square minus y square into cx minus 1 upon 4 is equal to x square plus y square upon 4. Okay, so now what we can do, in a very simple way, we can take the square root of this. Okay, taking the square root, so we'll have c, we'll whole have, no, we'll have cx minus 1 upon 2. Okay, so we'll have this, it will become c into x square minus y square is equal to x square plus y square whole square. This whole is minus, so it will be reduced by there. So we got x square plus y square into c, okay, is equal to x square minus y square, okay, which is the required general solution of the given differential equation. Okay, so that is how we try to solve the numerical. Now let us try to solve the fifth one. Now let us try to solve the fifth question now. Now we have to solve the fifth question. So now let us see what the fifth question they have given. So now let us try to find what the fifth question says. That is, we have to form the differential equation or the family of circles, okay, in the first quadrant which touches the coordinate axis. Okay, so here we need to form the differential equation or a family of the curve, family of the circles in the first quadrant which touches the coordinate axis. Okay, okay, so we need to form the differential equation. We need to form the differential equation of the family of circles in the first quadrant which touches the coordinate axis. Let us say this. We have center A. This is y-axis, this is x-axis. If I consider this we have x dash, y dash. So now what will be the equation of that circle? X minus a whole square plus y minus a whole square, okay, is equal to a square, because we have the a is a radius. So now let's try to differentiate it. We got 2x minus a plus 2y minus a into dy upon dx is equal to 0. And now we know the differentiation of constant is 0. Okay, so now let us try to solve this further. I got x minus a plus y minus a y dash is equal to 0. We have taken 2 common and take it that to the RHS side. Okay, so now I have, so x minus a plus y dash minus a y dash, x plus y dash minus, I am taking as here a I am taking common, so it will be 1 plus y dash is equal to 0. So now after that it will be, now what will happen? Take this x plus y dash is equal to a 1 plus y dash. Okay, so now I have taken this. We'll try to put the value here. This is the first equation we have. A is equal to x plus y dash upon 1 plus y dash. Now what we'll do, we'll try to put this value in this. So I got x minus a, that is x plus y dash upon y plus y dash whole square, plus y minus, we have x plus y dash upon 1 plus y dash whole square is equal to a square, x plus y dash upon 1 plus y dash whole square. So now we can say that if I try to solve this, if I take the LCM, x 1 plus y dash square minus x plus y dash whole square plus, so it's the whole square is this, no? Y minus a whole square is, no? Okay, so we have y so now I can eliminate the denominators. So now I have this. If I multiply x plus xy dash minus x minus, you have, that is y dash plus, so now next we can do here, it will become the whole square, plus we have y plus y dash minus x minus y dash whole square is equal to x plus y dash whole square. So I got this x y dash minus y dash whole square. Wait. Minus x minus a plus y minus x is equal to x plus y dash whole square. Okay, so this is the required differential equation. Okay, so I have just solved only 5 questions now. Let us try to solve the 6th now. Okay, now let us see what they have given in the 6th question. What we need to do is, we have just solved the 5 numericals. Now let us try to solve the 6th one. What the 6th says about, find the general solution of the differential equation. Okay, so this is a general differential equation they have given. 1 minus x square is equal to 0. Okay, so this is the, we need to find a general solution of this differential equation. Okay, so we have given the differential equation in which we need to find its general solution. Okay, now how to solve this? To find its general solution, you can write this differential equation as 1 minus y square minus, we have 1 minus x square. So now we have dy into, we have this, no? So we can, what we can do, dy upon 1 minus y square is equal to dx upon 1 minus x square. So now integrate both. So you got sine inverse y is equal to minus sine inverse x plus c. So now sine inverse y plus sine inverse x is equal to c. So this is the general solution for the given differential equation. Now let us try to solve the 7th question. We have just solved 6 numericals. Now we will see what the 7th question is given. Okay, now we, okay, now in this they have given this, that is a, they have given the, okay, 7th. What they have given here, let us see. They have given the general solution x cube minus 3, wait. They have given the x plus y plus 1. Okay, they have given this is equal to a, okay, is equal to a 1 minus x minus y minus 2xy. Now a is a parameter and we need to show that this is a general solution of the differential equation. Now they have dy upon dx plus y square plus y plus 1 upon x square plus x plus 1 is equal to 0. Okay, so we need to prove that this is a general solution of the given differential equation. So this is the 7th question. Let us see how we can do it. Now let us try to solve this differential equation. What we can do, we can put here upon x square plus x plus 1. Okay, so now what we can do here, y square plus y plus 1 is equal to minus dx. Now we'll try to integrate it, x square plus x plus 1. Okay, so we all know how to integrate this by completing the square. Okay, so by completing the square we can write it as, we know first up making the y square coefficient 1, then reducing by 2 or dividing by 2, that 1. So we have y, okay, here what we will do here, y plus y upon 2, No, what will happen? So what we can do here is y square plus, we'll try to by 4, no? So we'll try to see 1 by 4. Okay, so what will happen here is we'll try to solve this. Plus 1 upon 4 plus 1 minus 1 upon 4. Okay, so now here also same thing we'll do. That is x square plus x plus 1 upon 4 plus 1 minus 1 upon 4. So here we get dy upon y plus 1 upon 2 whole square plus 4 root 3 upon 2 whole square is equal to minus dx upon same x plus 1 upon 2 whole square plus root 3 upon 2 whole square. Now here we have this, so now we can integrate the formula. We have x square plus a square upon x square plus, we will have tan inverse x upon a. So I'll have tan inverse x upon a. We have this minus, we have tan inverse x upon a. Okay, so we have this plus c. Now what we can do? We can take this side, tan inverse plus tan inverse is equal to c. Okay, so now what we can do here, if I take the tan here, okay, so let us try to solve. Now here I can get tan inverse x plus tan inverse y will be tan inverse x plus y upon 1 minus xy. That is the formula we have. Okay, so that is tan inverse x plus y upon 1 minus xy is the formula for this. We have c here. So now we'll try to sort it out this. So what I will get here? Tan inverse y plus half plus x plus half upon root 3 upon 2 is equal to c. Okay, so now we have here tan inverse 2x plus 2y plus 1 upon we have root 3. Okay, that we have put upon 1 minus xy. Sorry, I have put simple now. We'll try to see here upon 1 minus xy. So we have 1 minus y plus half upon root 3 upon 2 into x plus half root 3 upon 2. Okay, so clearly I have put the formula here, that is tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Okay, so now I have this 2x plus 2y plus 1, taking LCM by 2 it will be reduced. Okay, so upon root 3 is there. Now we have this, so we need to sort it out first. So we'll have 1 minus, we have x plus 1 upon 2 whole square y plus 1 upon 2 we have, no, also we will have this upon 3 upon 4 is there. So this I have is equal to c. So now what I can do here, in a very simple way, we'll take that 10 that side. Okay, so will happen, we have this 2x plus 2y plus 1 upon root 3 upon, we have this 1 minus x plus half y plus half upon we have 3 upon 4 is equal to 10c. Okay, now just remove the 10 from this. Okay, so now here I can solve this, I got 2x plus 2y plus 1 is upon root 3 here. I have got 3 minus 2x plus 2y plus 4xy upon, okay, so I have this. And now we can write this, okay, this is what C here. So now we can write this root 3 2x plus 2y plus 1 upon we have here 3 minus 2x plus 2y plus 4xy plus 1 here is equal to C. Okay, so what I got here. Now let us solve it further. We'll take this on that side. Okay, so now let us try to solve it here. So now what we have here in a very simple situation, we'll take this root 3 2x plus 2y plus 1 is equal to C into, I can take it as C1, okay, into 3 minus 2x plus 2y plus 4xy plus 1. So now what we can do here, 2 root 3 x plus y plus 1 is equal to, if I take this C1 into 3 minus 1, it will be 2 minus 4xy minus 2x minus 2y. Taking 2 common, we have this x plus y plus 1 is equal to 2 into C1. We have here that is 1 minus 2xy minus x minus y. We have take this that side, so got x plus y plus 1 is equal to C1 upon root 3 into 1 minus x minus y minus 2xy. Here I can write x plus y plus 1 is equal to a 1 minus x minus y minus 2xy, where a is the parameter. Okay, that is how we can do it. We need to prove that this is the solution of this differential equation. So likewise we are able to solve the numerical. Now we will try to solve the 8th question now. Okay, we have just solved only 7, so now we'll move on to the 8th numerical. We've just solved 7 numericals. Now let us see what the 8th question says about. Sorry. We have the 8th question, that is, find the equation of the curve passing to the point 0 pi by 4. Okay, whose differential equation is given, that is sin x cos y dx plus cos x sin y dy is equal to 0. Okay, what is given in this is we need to find the equation of the curve passing to this point 0 power 4 and whose differential equation is given this sin x cos y dx plus cos y cos x sin y dy is equal to 0. So now let us see how we try to able to solve this question. Now let us try to solve this. Divide this equation, differential equation, by cos x cos y, both sides. Cos x cos y is equal to 0, because divide 0 by any number you will get 0 only. So we got here 10x dx plus here I got 10y dy is equal to 0 here. So now what we can do, we can integrate it. We got log of sec x plus log of sec y is equal to log of See, okay. So now we have sec x sec y is equal to 0, or you can say is equal to c. Sorry, c. We have removed the log a, log x plus log y, log x y. So now sec x. Now we know the equation that passes to this point. So x is 0, cos sec 0 will be reversal of cos 0. Cos 0 is 1. So 1 into sec 45, reversal of cos 45, root 2. So we got c is equal to root 2. You can put here value sec x sec y is equal to what? Is equal to root 2. Now we can write sec x upon cos y is equal to root 2, or cos y is equal to sec x upon root 2. Okay, so this is the equation which they have asked, that is the equation of the curve passing through this point, and its differential equation is given. Okay, now let us try to solve the ninth question. I hope it's clear to everyone. Now we'll try to solve the ninth question. We have just solved 8 questions. Now we'll try to solve the ninth question now. Now they are asking about to find a particular solution of the differential equation. Okay, they have given the differential equation now. What they have given? 1 plus e raised power 2x dy plus 1 plus y square e raised power x dx is equal to 0. Okay, so we need to find a particular solution of this differential equation, and we have given that y is equal to 1 when x is equal to 0. Sorry. So in this we need to find a particular solution of this given differential equation when y is equal to 1 when x is equal to 0 is given. Okay, so let us see how to find a particular solution. Okay, now we'll try to rearrange this differential equation. How? Let us see how we'll able to do it. What we can do here is, in a very simple way, take this here. So dy upon 1 plus y square integrate is equal to e raised power x dx upon minus, it will be 1 plus e raised power 2x. So now I got this. Okay, now 1 upon 1 square, a square plus x square will be tan inverse y is equal to, we have, now we'll put here, put e raised power x is equal to t. So write e raised power 2x is equal to t square. So I have this. Now ex dx will be dt. Okay, so now I have dt upon 1 plus t square. So I have tan inverse y is equal to minus, it will same will be tan inverse t plus c. So tan inverse y is equal to minus tan inverse e raised power x plus c. Okay, now I have this. Now I can put a value they have given. X is 0, so y will be 1. If it is 1, so it will be pi upon 4. Y will be 1, we can write 10 pi by 4. So we will be pi by 4 is equal to, now x is 0. Something having the power 0 to be 1. So it will be minus tan 1 plus c. Okay, so that is we have. So now we can say it's tan inverse 1. So same situation will be there. Minus pi by 4. So pi by 4 plus pi by 4 is equal to c. We'll have pi by 2 is equal to c. So here we can put the value, that is tan inverse y plus tan inverse e raised power x is equal to pi by 2. Okay, so that is how we able to find the particular solution I have, particular solution of the given differential equation. Okay, now we have the 10th question. So we have solved 9 numericals. Let us try to solve the 10th. So now you have the 10th question now. So now 10th question I have. But the question is, we need to solve the differential equation, that is y e raised power x upon y dx is equal to x. X we have e raised power x upon y plus y square dy, where y is not equal to 0. Okay, so what we have to do, we need to solve this differential equation. Okay, they have given this. Okay, so let us try to solve this differential equation. Now we'll try to solve this y e raised power x upon y dx upon dy. I am taking this. Okay, so we know the question that is we need to solve that differential equation. Now let us see how we can do it. We have x upon y plus y square. Okay, so now what I can do, I can take this side common as y e raised power x upon y dx upon dy minus x e raised power x upon y is equal to y square. Now take e raised power x upon y as common, y dx upon dy minus, here we have x, okay, is equal to y square. Or what else I can do? I can do it both sides of y square. So I got this y dx upon dy minus x upon y square is equal to 1. Okay, so now we have this. What we can do, put e raised power x upon y is equal to t. Okay, so let us see what we have. Now what we can do here, consider this is as first equation. Now differentiate it. We got e raised power x upon y. Now differentiation of x upon y will be by u upon v. So what we can do here in a very simple way, y into dx upon dy minus x, okay, upon y square. Okay, we have dx is equal to dt. So now what we have here, if I consider this now, this is what we have, e raised power dx upon dy, okay, is equal to dx, this I have differentiated, so I got dx is equal to dt now. Okay, so now I can consider this. Okay, so here I got what, this whole will become dt. So now what we have, we'll see. So now we have this. Okay, so now comparing both, what you got here, dt upon dx is equal to 1 or dt is equal to dx. Now what we have is in this, so now we have dt is equal to dx. Okay, so now if I integrate this, I got t is equal to x. Now what is t I have taken here? If I consider this, t I have taken e raised power x upon y, e raised power x upon y is equal to x. Now this is the required equation. Okay, so we got this. So now this is the required, solution of the equation. Now we have solved only 10 numericals. Now let us try to solve the 11th. Okay, We have solved this differential equation. Now what the 11th is, they have given, that is, find a particular solution. Okay, in 11th question we need to find a particular solution. We need to find a particular solution of a differential equation. They have given x minus y dx plus dy is equal to dx minus dy. So we need to find a particular solution of this differential equation. They have given that y is equal to minus 1 when x is equal to 0. Okay. Now they have given hint also, put x minus y is equal to t. So now let us try to see how we can solve this differential equation and need to find a particular solution of this. Okay. So in this we need to find a particular solution of this differential equation, and they have given the condition also. So now let us rearrange this. Y dy is equal to dx minus dy. Take that side, x dx minus y dy minus dx plus dy is equal to under. Take x common, x minus 1 dx plus 1 minus y dy is equal to under. Now take that side, 1 minus y dy is equal to x minus 1 dx. Now we have dy upon dx. Upon dx will be x minus 1 upon 1 minus y. So after simplification, we will come to this point that dy upon dx will be x minus 1 upon 1 minus y. Now what we have, in a very simple way, instead of separating them, we can do like this: x minus y dx plus x minus y dy minus dx plus dy is equal to 0. So now x minus y minus 1 dx plus 1 plus x minus y dy is equal to 0. So now what can I do here is, in a very simple way, if I take that side common, 1 plus x minus y dy is equal to minus of x minus y minus 1 dx. So now dy upon dx is equal to minus x minus y minus 1 upon 1 plus x minus y. So now I have this dy upon dx is equal to this they have given. So now I can write as 1 minus x minus y upon 1 plus x minus y is equal to dy upon dx. Okay. Now what we can do here, put x minus y is equal to t, so that 1 minus dy upon dx is equal to dt. Okay, minus dy upon dx is equal to dt minus 1. Okay, or if I take common minus, it will be dy upon dx will be 1 minus dt. Okay, so now I can write as 1 minus dt is equal to 1 minus t upon 1 plus t. Okay, so I have this. So we have, now we can consider this. So now we'll have dt upon dx. So we have 1 minus dt upon dx is equal to, take minus sign common as it is. Okay, so minus dt upon dx plus 1, we have this. Okay, so it's plus 1, it will minus. So now we have minus dt upon dx is equal to, we have minus t minus 1 1 plus t, it will minus 1, take minus 1 common, it will reduce, so we will have dt upon dx is equal to t minus 1 upon 1 plus t plus 1. So now it will be, we'll try to solve here, dt upon dx is equal to t minus 1 plus 1 plus t upon 1 plus t. So we'll have 2t upon 1 plus t. So now what we can do here is take that side common, 1 plus t, integrate it with dt, and take also here will be upon t. Okay, so here we'll have dx, 2 dx. So now we know that we can sort it out like this, that is 1 plus 1 upon t. Okay, dt is there, is equal to 2x. So now we need to integrate this. So we have t plus log t is equal to 2x. So we have plus c is equal to 2x. Now if I put x is equal to 0, okay, put t. What is t we have taken here? What is t? X minus y. So x minus y plus log of x minus y plus c is equal to 2x. Okay, that is what we have. Now we'll take that side common, so we have log of x minus y is equal to x plus y plus c. Now we can put a value here that x is 0 and y is minus 1. Minus 1, so it will be log 2 is equal to x will be 0, so minus 1 plus c. It will be, so we have this value we have, so 1 plus log 2 is equal to c. So here I can put my value. So I got log of x minus y is equal to x plus y plus 1 plus log of 2. So that is how we able to solve that question now. So now we have solved 11 questions. We have find a particular solution for that. Now let us try to solve this 12th question now. Okay, so I've just solved 11. Now I am on 12th question now, what they have given. So now what the question is, let us try to find. They have given that 12th question, we need to solve this differential equation upon root x minus y upon root x. We have dx upon dy is equal to 1, and this they have given x is not equal to 0. Okay, so we need to solve this differential equation. We have solved 11 questions. Now this is our 12th question from the miscellaneous exercise. So let us see how we can solve this. Now we'll try to sort it out, this differential equation. How? In a very simple way. dy upon dx. Now e raised power root x is equal to dy upon dx plus y upon root x. Okay, so now we have this. So I think we can compare now. This is a linear differential equation. Here p I have 1 upon root x, and q I have e raised power minus 2 root x upon root x. Okay, so now let us try to solve this. That is how we can solve in a very simple way. First find the integrating factor, e raised power 1 upon root x dx. So now if I try to integrate this 1 upon root x dx, so what I will get here, minus half plus 1, half we have, into, we will try to put minus half plus 1, half, so it will have, it will 2 this. So now we will try to put here y into 2 root x is equal to integration. What is q? We have e raised to power minus 2 root x upon root x. We have into 2 root x dx. Now we have y into e raised to power 2 root x. Okay, root x is equal to, it will be 1 upon root x. So plus c. So now if I integrate, I got what? Minus half plus 1, root x, 2 root x upon e raised power 2 root x plus c. So finally, we are able to solve that differential equation. Okay. Now let us try to solve the 13th numerical. We have just solved 12 numericals. Now let us try to solve the 13th numerical. Okay. So now they have given the question, that is, we need to find a particular solution of the differential equation that is, they have given dy upon dx plus y cot x is equal to 4x cosec x. Okay, so they have given the differential equation. Okay, and also they have given the condition that y is equal to 0 when x is equal to pi by 2. Okay, so now we need to find a particular solution of this differential equation. If I consider this, we have p, we have cot x, q, we have 4x cosec x. So this is a linear differential equation. Now let us try to find first integrating factor, that is e raised power integration of cot x dx. Okay, so now we need to solve this question. So now we have e raised power log of sin x will be sin x. Okay, so now after finding the integrating factor, we'll try to solve here. Write y into integrating factor is equal to q, 4x into cosec x into integrating factor, integrated with dx. Now y sin x is equal to, take 4 outside, x I can write cosec x as 1 upon sin x into sin x dx. So we have x, so we have y sin x is equal to 4 integration of x dx. We got y sin x is equal to 4 into x square by 2. So now I have y sin x is equal to x square, 2x square plus c. So now they have saying that x will be pi by 2 when y is 0. X is pi by 2, sin 90 will be 1 is equal to, we have we can x is pi by 2, y is 0. Okay, so it will become 0 is equal to x is pi by 2, pi by 4, so we have pi by 2 plus c. So here c is minus pi by 2. So now I can put a value here. So now I got y sin x is equal to 2x square minus pi by 2. Okay, so that is how we able to find a particular solution if the differential equation is given. Just we need to find the type of the differential equation and we able to solve it. Now let us try to solve the 14th question now. We have just solved 13. Now we'll try to solve the 14th. So we have 2 more numericals to solve. Then after that we'll try to solve the next chapter. Okay, so now 14th question they have, that in this we need to find a particular solution of the differential equation. They have given x plus 1 dy upon dx is equal to 2 e raised power minus y minus 1. And they have given that y will be 0 when x is equal to 0. So they have given that differential equation, and in this we need to find a particular solution. So let us see how we able to solve this. Okay, so we have. So now let us try to find the particular solution for this. X plus 1 dy upon dx is equal to 2 upon e raised power y minus 1. X plus 1 dy upon dx, we have e raised power y upon e raised power y. Okay, so now what we can do here, we'll try to solve this. E raised power y dy, okay, upon 2 minus e raised power y is equal to, we'll take dx upon x plus 1. So we'll have log x plus 1. Here put ey as t. So ey dy is equal to dt. So dt upon 2 minus t is equal to log of x plus 1. We have log of 2 minus t minus we have log of x plus 1 plus c. Okay, so now we can take log of x plus 1 plus log of, put t value e raised power y is equal to minus c. Okay, so log a plus log b, log ab, x plus 1 2 minus e raised power y, we have minus c. Okay, so now we'll try to solve it. Now what we can write here, x plus 1 2 minus e raised power y is equal to e raised power minus c, and we have this in that form, so we'll write plus minus. Okay, so now what we can do here, now it will be x plus 1 2 minus e raised power y is equal to c. Now put value x0 y1, so we'll have c is equal to 1. So now we can try to put here x plus 1 2 minus e raised power y is equal to 1. 2 minus e raised power y is equal to 1 upon x plus 1. E raised power y is equal to minus 1 upon x plus 1. We have 2x plus 1 upon x plus 1. So what we can do now, take log both sides. So we have log of ey is equal to log of 2x plus 1 upon x plus 1. So we have y is equal to log of 2x plus 1 upon x plus 1. Okay, so that is how we find a particular solution of the given differential equation. Okay, so now we'll try to solve one more question so that we'll able to finish this exercise. That is, now we have 15th question now. Okay, so now we'll try to solve this 15th question. So now what they have given is, in this they have given about that the population of a village increases continuously at the rate proportional to the number of its inhabitants present at any time. Okay, so if the population of the village was 20,000 in 1999 and 25,000 in year 2004, so what will be the population of the village in 2009? Okay, so now we'll see, let P be the population, P be the population of the village at time t. Okay, now according to the question, rate of increase in population, rate of increasing population is proportional is proportional to the number of inhabitants. Okay, so now let us see what we have. Now we have, that is, dp upon dt is equal to kp. K is constant, but k is more than 0. Values will be more than 0 because the population is increasing. So now what can I write? dp upon p is equal to k dt. Let's integrate this. So we got log p is equal to kt plus c. So now this is the first equation. Okay, so ये ना बस होने वाला मेरा इतना बड़ा क्वेश्चन है और मैं now we have, that is, log of 25,000 upon 20,000 is equal to 5k. We have log of 5 upon 4 upon 5 is equal to k. Now putting this value of k in this, so I got here, that is, log of p upon 20,000 is equal to 1 upon 5 log of 5 upon 4 into t. Okay, so we have this. Now we'll try to solve when we take t 10 years. Now we need to calculate 10 years, that is from 2009 to 1999. Okay, so now we'll put the value of t here. So we have log of p 20,000 is equal to 1 upon 5 log of 5 upon 4 into 10. So we have 2. So now log of p 20,000 is equal to 2 into log of 5 upon 4. We can put log p upon 20,000 is equal to log of 5 upon 4 whole square. Okay, so now we have p upon 20,000 is equal to 25 upon 16. Now p is equal to 25 upon 16 into 20,000. So now we can easily solve this by reducing 4. Okay, now 4 we can take 8 0. So I got exact population, that is into 25. So finally I got the population. So we have exact value 31250. Okay, so that is how we able to find the population of the village. But they have asked, that is what they have increased, no, from 1999 to 2004, and after that 2004 to 2009. So we have taken different conditions here. Okay, first, in case we have initially in 1999 they have given the population 20,000. So we have taken that time t is equal to 0. So we have put this value in this, I got this. And after that, in 2004, that is after 5 years, the population was 25,000. So I put the value in this and find the value of k. And after finding the value of k, I have put here. And after that, after more 5 years, that is in 2009. So we have now 10 years. From 1999 to 2009, we able to find the population, that is exact population was 31,250. Okay, so I hope it's clear to everyone. We able to solve all the questions from the miscellaneous exercise from the maths class 12th differential equation. If you have any doubt, you can ask, you can comment, and please share my channel, and also please like my channel. Thank you.